Hey everyone, Nicholas JMV here. We're going to be evaluating composite trig expressions today. You need to know about trig functions. You need to know inverses for this video. The ones that I'm going to do today are ones that you cannot find on the unit circle easily, okay? And we're not going to be using a calculator. So an example of this would be find the exact value of cotangent of inverse sine of negative 1/3. So we're going to use pictures today to help us. And so let's think about what's going on here. So composite function, we got to be thinking inside. Okay, so inside, inverse sine of negative 1/3. That tells me what angle, what x value is going to give me a y coordinate of negative 1/3. Okay, that's what I got to think about. So I'm going to use a drawing. I'm going to use a reference triangle here. And I know sine of x is opposite over hypotenuse, right? SOHCAHTOA. All right, and so I'm going to draw this down to like -1. So here is -1. It's my y value. Okay, my hypotenuse has to be 3. So with respect to theta, opposite over hypotenuse. So there's what the drawing of this is looking like. And so what we're going to do now is find our missing length. Our missing length here is x. We have a right triangle, so let's use Pythagorean Theorem. Okay, x squared plus y squared equals c squared. My y coordinate's 1, so I have x squared plus 1 squared equals 3 squared. I'm really going to ignore the negative here because if you square any number, it's positive. So I get x squared equals 9, x squared, plus 1 equals 9. And then I subtract 1 from both sides. I get 8. Square root that, I get x equals √8, which becomes 2√2. So there's my x coordinate, 2√2 right there. So I've set up my angle, my inverse sine of negative 1/3 here. I've set up the angle. Now I'm going to find that cotangent. So this picture is really setting up that angle. So I don't have an exact angle here, theta, but I know that cotangent of theta is the inverse of tangent, flipped, right? So what we're talking about here is not y over x, we're talking about x over y. We know the x coordinate is 2√2, and we know the y coordinate is -1. Okay, so our answer here is -2√2. That is what cotangent of inverse sine of -1/3 is. It is -2√2. So I've got one more example to show you. It's very similar. Find the exact value of cosine of inverse sine of 4/5. Same thing. Start with a triangle here. So we know that 4/5 is what we're looking for. So we have sine of some angle equals 4/5, meaning what angle gives us a y coordinate of 4/5. Okay, so I draw my figure. Both are positive. The y coordinate is 4. The hypotenuse is 5. Okay, so here's our picture. Pythagorean Theorem. X squared plus y squared equals c squared. So you have no x. We're finding x here. Plus our y coordinate is 4. 4 squared equals 5 squared. So 16 equals, so x squared plus 16 equals 25. X squared equals 9 by subtracting 16 from both sides, so x equals 3. There's our x. So we've set up inverse sine with respect, okay, with this reference triangle here. So now we need the cosine of this reference triangle. So cosine, remember, theta is equal to adjacent x over hypotenuse, or x over r, depending on your text. The x coordinate is 3. The hypotenuse or radius is 5. So that, everyone, 3/5 is the x coordinate. So, right, cosine here means we're going to have a coordinate. Inverse sine is an angle. So we set this up. So cosine of inverse sine of 4/5 is 3/5. Okay, so those are a couple of examples of composite functions and some values that are not necessarily found on the unit circle. And these are exact values. Okay, so if you have any questions or comments, let me know, and we'll see you next time.